start. I let people come in. Just to warn you a bit and avoid any frustration, this talk is not about making money, it's about daily billions of events, not dollars. Then just to be sure that we are talking about the same thing, and it's about a story about backend development in Kotlin. My name is Arnaud Giuliani. I'm co-founder of company Kotzilla, which is a company that is making work about Kotlin and open source, and I'm a creator of Koin project and also Google Dev expert. Where does all this story begin, really? It's all about a startup story and where finally we begin to work on Kotlin. All start about Koin. Koin is a Kotlin dependency injection framework, one of the most famous one. And this framework has been created in 2017. Then it's really well used in many ecosystems, from mobile to multi-platform and even backend. A few good names that are mobile application users here that are using this framework, and we are super happy to help them and really help the ecosystem to make really better every day for the Kotlin developers. As long as, yes, we, as a company, we provide official enterprise support and we help people about Kotlin multi-platform, and all about architecture with dependency injection. The idea for this adventure is really, and is still there, is how we can provide more value about open source, about everything. Because then we have a great solution, a great open source framework, but then what we can provide that really help you more in a daily basis as a really professional tool. And regularly, the story I see around, as I've been previously as tech lead in many companies, and the story are always kind of the same, as we regularly see technical debt, non-scaling architecture, finally applications are collapsing, and delivery is going down without anyone in the team don't really know where is it. In general, really understand well, but finally we don't have really any data on that. And this is the idea for us, the starting of our story, is really at Kotzilla making a dev platform to help and debug app architecture, try to spot refactoring, memory and performance issues, and all of this really at the development perspective, also in the monitor to the production for all the behavior for people. And really in the idea to help you drive better delivery for your product, because then if really you know where it's struggling, then you can deliver in a better way your product. And really, I believe I have some internet issues, because if I don't have my fun animation, it will be less fun. Let's try the fun stuff of Canva. Okay, you see, it should be like that. Then let's start. Let's build it, okay? And that's the start of our adventure. Okay, the idea is great, but then we need building blocks and we need to go fast because we are a startup and we don't have unlimited money, and then we need to go and deliver fast. Then, okay, we need something to help reach our MVP, to go in fast iteration, and then really help us deliver in a fast way. This is our main architecture diagram, not super heavy, you see. We want to capture mobile architecture data and send everything to our servers. What we want really is a simple stack in Kotlin to really iterate super fast. And do we take risk here? Because then in terms of Kotlin stack, we would like to go with Ktor, and yeah, it's not Spring, it's not what you see in all the JVM stuff around. For us also, it's a question of continue to push the community for the community and the development technology with Ktor and Koin. And then what's best finally to develop in-house everything that is a part of this experience and could really help improve Koin for the development of Ktor and the web application. And then we go for this web application stack. We just want a database. We really want to stay simple things. And then here's how we are really describing our stack. Web application with native, Ktor, Koin for dependency injection, exposed for data storage, and PostgreSQL for data storing. Why? Because finally we are all the people, and we still know relationship data. Then we still believe that it's a good point to start with relational database. And we are a small team. Then what we want is deliver. Then let's focus on delivery, but also let's focus on having super simple building blocks. And for that, we want to go for something that you just take your application, you push, and it's go to prod. Nothing more. We don't want to really bother with lots of administration. We can't. We have a small team. We are only a few developers. Then, yeah, no DevOps team. We are all DevOps then. And we need to do with what we have. Our choice here was to go with the Google platform, as the promise for Cloud Run really was to help us in terms of deployment as container and auto-scaling. That sounds good really for us. And we could really find easily samples on internet about how we can deploy into Cloud Run with Ktor. The other point is having massive file storage. Why? Because we are dealing with model of your architecture, and it's a model that are kind of stable or not, and we want to change, then we want massive file storage. Best for that is Google Cloud Storage, like S3 for AWS. And of course, we will have many applications. What we will have is the need to pass message around. Then we do massive message queuing, and for this we use Google PubSub. Then really, the idea is simple primitives to really build our applications. I will show you how we develop internally with the Koin Ktor expose, and how we can go fast with Ktor, and enjoying Kotlin daily at Cozilla. Then it starts something like that, where we have an entry point for our application. This is how you start Ktor. Here we are starting our common Ktor plugins, where we have all common configuration. And we start by configuring our dependency injection and many other common plugins that we may have, like JSON compression, cores, and so on. Then this is the common stuff plus the model of dependency injection we want. Then we are using the database. Then we are connecting the database with that. And now we can expose our routing. And all the routing in Ktor are extension function to expose routes for HTTP service. In terms of persistence, we try to have naming standard, like this is how you begin to write table in exposed, like it's an object class, it's a static class with fields, and then you see that it's SQL fields that are described here. And then we have a users table, and we have also the user DAO. It's part of the expose framework to be backed on a table for metadata and then expose those metadata directly with entity. What we like is having the right naming in terms of persistence to have the DSL, the SQL DSL on one side to understand that you are really managing DSL stuff, and on the other side that you are using DAO for persistence and all the DAO patterns. And then on the DAO class, it's a normal class that will have all those DAO operations, like create, like new, and have this backing field back to the SQL queries. But we try to have naming, and you will see why. Because when we are using and writing our repository, finally, with just a class, we need to have transaction enabled in our repository, because then a repository is making operations in DB. Then what we have is a context parameter with a transaction to say, hey, guys, I need a transaction here. And then in each operation, we will have a transaction created at the upper level. And then you see that here I can create user DAO entity new. Then I'm creating a new entity here quickly. And on the other side, I can use users table when I'm using and handling the SQL DSL. Then really, I can visually really make the distinction between user, the DSL, and the SQL side. And finally, it goes really, really fast because then it's how we write a route, for example, to create a user. We retrieve our user service with Koin by this way, using user service by inject or user service, and then we can use it in our post service here, where we want to fill with data. You can see here that we are receiving and retrieving a JSON body, and then what we are using is Kotlin serialization, and then this is all the data class that we can handling. That is the whole body object of what we are receiving as the JSON object pushed by our web platform. And then we are using our business service, this business service that is finally calling all operations for us and creating the transactions. In Expose, you need to open blocks with transaction lambda, and then you know that at this point you are writing in your database. You see, finally, it's really quite easy and fast to really drive into our development. And then now we have a few services, we have a few things. We can now push it to Google, just having the few Gradle plugins. You just use Ktor plugins, for example. You can write your manual Docker file, or not. You will see that there is a plugin for that. Just Gradle you assemble, and then you can use the Google Cloud CLI to push directly in one line your Docker application directly to the cloud. And then you're live, and that's great. If you want to look at the plugin documentation, there is this page, Ktor docs, then where you can find all those. And of course, behind that, our applications are locally running in less than half of a second, and in production, on Cloud Run, all infrastructure and production applications are still starting in less than 3 seconds. And really, it's super useful for us because really we can swap and really reload or start new application or container, and it really without any interruption of our service. We begin to write a few services. We begin to have fun with all we had, then we know that it's really working because we have a few applications on locally. Now it's time to really dive into the void and then see what's going on with real thing, okay? Because this is what we want to do. Mobile architecture capturing, we have data, we want to store them on our servers. Now, in a few weeks, in 8 weeks, we were able to have all the storage of our events in DB, and then having it ready to be storing things on Google Cloud Storage, and a few light analyses, then processing about JSON, and then mapping data. What we need is we bring a special SDK to capture this architecture data on the mobile application. The more or less fun thing is that finally we are exposing ourselves to millions over billions of devices that will send data, because then each time you have an application that is subscribing to our service, then it can be for a few thousand users to hundred thousands of users, even millions of users. Then, yeah, we will have a potential factor of scalability that will be huge. And to be sure that we can really handle everything, we need something to be sure that we can kill completely the traffic and kill completely and handle completely all the bandwidth, all the data that are going. And we don't want to impact people with our SDK. Then we need to be sure that if there is fire everywhere, we can really cut everything, and you don't understand, you don't see that there is any impact on our side. The good side also for us is to be able to reestablish any traffic or any connection with our client if there is any kind of incident. But then with this kind of mechanism, we are ready for that. We are ready, and we want to time box this because we don't want to go in the nature with all those data. And we are starting to try to experiment with 100K session application to really measure that really we can really scale and we can really absorb all of that. It should be something around 20 gigabytes, okay? The problem is we went to 360 gigabytes in 2 days, and then it was something like 1.7 billion events in those days. That was really super huge, and it was not 100K session, but more around something like 1 million. Then it was a first surprise. The other good surprise that finally everything scaled. and we didn't have any interruption. Also because our credit card was scaling too. Then, yeah, the good thing, we will see that we learn to scale and have more mechanism for that. Really, as we are started to try to have the best developer productivity, and what we want is really avoid to have all the simulator, avoid to have all those servers locally, because you have the servers, you have to set up everything, and then that's beginning to be a nightmare. And then what we would like is that our developer in our team abstract away from messaging and file storage. And what we do is that with Koin configuration, we can easily say in our configuration that we are creating a class called database config. We can use Koin to say get property on null, and then it will load things from your environment. And on the other side, when we have dynamic stuff, we want to really to separate configuration between production or local. We can really have a Boolean expression, because Koin is based on pure Kotlin DSL, pure Kotlin expression. And then we can have both definition, like a local storage repository, I'm just storing file, or the Google Cloud one, where we are adding blobs and stuff, and the API is not so fun to handle. But then it's completely transparent, and we are okay to take the risk for that. The good thing also is that we could swap things super quickly, and then we can really avoid to have hot reel, because our startup time was really start. But we need sampling and rate limiting. Rate limiting is where you don't want all the people to call you, and you want to say, hey, stop calling me, you slow down, please. And you want to really control completely the traffic that is coming to your servers. You can do that with all, and Ktor has all authentication and rate limiting plugin ready. Documentation can be found here, server rate limit, HTML documentation, and just a few plugins you can tune in how you permit people to go to your servers and then allow them to use your service. And that's including, because it could be a risk that there's nothing like that, and we would have to write by hand such mechanism. It would be a risk for us, clearly. The other point is that we have so much data, we can't really have object mapping like expose framework. And then we decided we can't really use DAO approach like we would do normally in any application, just using DSL for all the queries and DAO for all the object creation and all the data. Because then it's really more easy to have our object and graph creation with the data class and everything, but then when we need to request, we need to go super fast, then we have this DSL. And then also, in terms of tuning, we looked around a few times, because you have to tune with a kind of exotic stuff with Ikari data source. And on Cloud Run, if you don't use those settings, you're quite sure that your container won't scale, and they will use a connection with all your database and stuff. Because then we are simple then. We are using Google SQL with the PostgreSQL server. That's fine, okay. Run our SQL server, but then each time you pop up a new container, you must be sure that the thread pool behind is still connecting and still handling all the resources. And for that, you need to use this configuration with Postgres, with the Cloud SQL instance, and also all the tuning and connection time, you need to use that. It's deep somewhere in the Google documentation. You have to scratch a bit, but then use those numbers, and your container will scale with Cloud Run easily and with the SQL connection. And then we learn to scale from monolith, one big application, to smaller ones, and then distributing all our data processing. Because then we begin to have specialized way of having data processing, and then we need also to discover more and more the data. Then we need to use our messaging pattern with that, with a simple PubSub. Just as a reminder, then in PubSub, you can have two configurations. Push, you have a message that is pushed to your container endpoint, and then it's receiving your message. And on pull, then your container is subscribing to this queue and then unqueuing everything by hand. This is the two strategy that you have, because then you can't deal directly with billions of messages coming directly on your servers. You have to take them and throw them on the queue and don't do anything at start. And then you start analyzing and then be sure that you are dealing with your data. And then this is the question, push or pull? Then what do you do? What's the best? How we can scale with that? And this is one of the strategy for us to really try to understand is how we can really tune our scaling, tune the way that we are controlling our data, because we don't want to burn cash forever, because then we won't be able to sell those services, but then we want really to be as efficient as possible. In between, we need to test and deliver, and in a few lines, I will describe how we begin to test our infrastructure. We are using test container with Koin and JUnit, of course. JUnit for the classical unit tests that are using our components. And mainly what we are doing is we are using lots of test containers, service integration, and trying to play with services, a few bench of data, and then running on that. With Koin, I want to avoid to test at the website. I would like just to test at the service side. Then I will ask Koin. This is how you can create Koin instance to retrieve your dependency injection engine. You just set up it like that, Koin application, modules, and the modules you want. Don't forget .coin at the end, else it will just be the configuration start. And then this way, you will describe delegate injection for your service. Then you use my service by coin.inject. That will make the delegate for this service. And then you're done. It's a delegate that's in a lazy. Then you can use those references directly in your test, and then you can you can run stuff in parallel for that. And that's super interesting and super quick to do. You run with your own test, and as we are doing abstraction between local and production services, then we are playing a lot with local stuff, trying really to avoid any production issue around that. Test container. We are using the test container API. What we do usually is that we are starting Koin, we are starting a connection services, and then we are starting a container with PostgreSQL container. We are using Docker image, etc. And then here we start PostgreSQL container, and then we start the connection with our service, and then we can run stuff. This is an extract of our abstract class for test. And then once everything is done, then we can shut down everyone and then say, okay, now we can just trash all those data around, and that will be it. The other point we have is usually we have the need of multiple Ktor instance. Why? Because we ended to have a specialized web application, like exposing those API, exposing the data processing, having our main server that are storing everything. Then we ended having specialized application, and then at the end, you need, at least to make some end-to-end integration, we need to have a few Ktor, multiple Ktor instances in parallel for that. In our graph here, what we do is really simulate the fact that we have multiple container, and then we have multiple application, and we have a special local configuration that will help us really test that locally. We don't want to make tests against the real database or against real pub/sub. Here it's really local test. Then we use PostgreSQL container, our friend, and this is the way we are dealing with different kind of server module. Then what we do here is we have all our servers that are created in each instance of embedded server, and then at the end you see module.application A module or B module. This is your Ktor module that you are describing. And then each one must be on a different port, else we'll have some problem. But then this way we are really launching simultaneously many Ktor instances. And then before running everything, then we can start all the container, we can start the server, we can start everything, and once everything is ready, then we can really stop our container, and that's fine. The other way that now we are testing, we need also to be able to deploy, redeploy, have an issue, cry, and then come back to something. And then we try to have a plan to quickly really deploy. And what we decided is really having kind of Git flow where we could really deploy on tags. That means that each time we are ready to deploy, then we go to master and say we deploy. And this deployment is calling our CI to deploy on the Cloud Run on the right container. Because then at the end, what we are doing is we are targeting all our configuration environment from Git, and then we can be sure that we know what version of our system we have deployed online. What is super interesting also is that you can have instant rollback on Google Cloud Run. That means that if you have problem, you deploy the container, you deploy an application, there is fire, you can just say, OK, roll back. And then you roll back to the previous container that you deployed. And then that's fine. Everyone is breathing a bit more in the team. And then you can really think to your fix now. But then there is many strategy either to roll back manually, either to try to redeploy something with the right tag. And then our configuration and our strategy to deploy things are bound to our way to deploy with Git. Then. The other way to go super fast is activating and deactivating features, especially for features that you don't know well if it's working or not. And when you are experimenting and you want your code to be delivered, what we usually have is regularly we are activating or deactivating part of our features thanks to something that is looking like that on flag. This is a local development that we have done, and it's looking at the regular flag value that is stored in our database, and then we have a local offline version, and then we can refresh it. But then that's something that really helps us really have a portion of code delimited by a feature flag, and then we can search for this flag to be sure that we can really deliver the feature or not, activate the feature. This is where, finally, it's interesting for us because we have reached some limits and we have encountered some problem. Then this is where we have more feedback about the great fun story where everything scaled, but finally also we learned many things. The first thing we learned was, the thing is that we had to write our own manual pagination for Ktor. That means for all our services, and we have large collection of data, we have to write our own version of limit paging and then be sure that we have a generic implementation of that. It's kind of something you could really find on Spring Data easily because it's part of Spring Data REST and all those kind of projects. But then here we didn't find really something and we had to write manually our pagination. We have large collection, we need pagination, then really that was a requirement that we missed a bit at the start, and we assumed that also on our side. The other stuff that was a bit kind of weird is that finally, for Ktor, generating documentation was a bit hard. At the beginning, we were quite happy. Why? Because we were able to generate everything from IntelliJ. Okay, that's cool, because in one click, you just open your IDE, and then you generate everything. Problem is that this generation is not really taking taking care about some security header stuff, and then if you have some configuration that are not detected by this tool from IntelliJ, then your documentation is not generating well, and then you need to write stuff and patch by hand everything in your Swagger file. That's not good, and also we didn't find any way to try to generate our documentation with Gradle, and then that was a big problematic for us, that every time we had to update our documentation, we had to patch by hand, try to find a diff in our documentation that was clearly awful. And then we tried many other things, and one thing that we tried, finally, it was to integrate Compendium. It's the project that you can find here on GitHub, where you can tune your Swagger server, and we tune our Swagger server to have manual description on our documentation. And then it's generating on the fly everything in the Swagger server. If you want to look at that, then you can take a look at the Compendium about document generation. Other things that finally we try to tame over time is using exposed, and then we learn to use exposed with the ORM and with the DSL. The problem also that we encounter is that the visibility of the usage of transaction block. Why? Because sometimes you want to reuse a service that is already using transaction, and you are using this or this that are using transaction, and you can miss easily the fact that you are already starting transaction, and then you are mixing some transaction block, and then can be not really the behavior that you are looking for. A part of that, all the Google API on Google Cloud not super Kotlin friendly, and especially on Google PubSub, where everything is in a blocking style. That means that you have to rewrite around to adapt this to the coroutines. The other point also is that we try to make things with flows and with channels around a PubSub client, and we had issue in the fact that it was not blocking directly, and coroutines parallel processing was not so great on Cloud Run. And then we went back to have a blocking API and use the blocking API for Google PubSub. And then we are launching coroutines after the client for Google PubSub. The problem of Cloud Run on mainly, I would say, container serverless technology is that you need to go and to understand how you're tuning your CPU and memory management. And then you don't know if you need to take a big server with lots of CPU, or you can scale with lots of little servers. And in fact, you need to really tune and test, because the reality is in between. You need really to test with your data, with your bandwidth, your everything, because you won't definitively scale easily with lots of little servers. Sometimes a bigger server will handle more processing than just a few container instances. The other stuff that we learned really lately, unfortunately, is that we have to tune the S-check service. The S-check service is the way for Google and Cloud Run to understand how your application is running. And then, because, for example, if you are running coroutines, the coroutines is crashing, yeah, everything is fine. And then your containers still continue to live, but no requests are processed, and then you don't know why. And then you have really to be sure that Cloud Run understands that there was something wrong and we need to restart your container. Let's go a bit more about that. I would say there's lots of learning about Cloud Run container, and especially as we were trying to simulate long-run processing. Why? Because on Cloud Run, when you try to configure Cloud Run, Cloud Run is especially done for having one-time container, then having requests, and then processing them and closing the container. If you are dealing with long processing, then you need to tune something around the Cloud Run in a way that is not really meant to be used. I explained that. You need to be sure that you hold a minimum of instance. That means that you don't say, if there is nothing to do, you can close everything. No, you need to keep something running to try to let Google Cloud Run be sure that they don't cut everything. And even more is not really, you are not sure that your container will survive to any kind of crash. The other thing you need to tune is the request timeout. How much time does this process will take? And even more, you begin to think about, yeah, I need CPU is always allocated or only during the request. And then if you don't tick this CPU is always allocated, you will have interruption in your container, and then you have crash in Ktor, say, okay, that's, I don't know what's going on, and then you are interrupted. Then you need to tune Cloud Run to hold everything as long as possible. The problem, if you are selecting a pool strategy on PubSub, then in Cloud Run, you have to work your own worker. Your own worker, that means that we are holding our long-running processing, okay? Then we hold artificially some container. You need to make your own worker infrastructure, because then you need to be sure that on your big Cloud Run container, you have threads, you have worker, then you can unqueue message, and then they are unqueuing the work in a good way. And then the problem comes here if your worker and your component are not linked to your status service, no one will see that, for example, if there's a crash in your worker, there's a problem. And you will see lately that there's a problem. Then be sure to tune your status service and be sure that you are returning the right HTTP status for that. For the push for pub/sub, you can lead to flooding your own server if you don't really tune in the way you want, because then it will push everything it has in the queue, and then as long as you have data, then it will push all the pressure to your own server. And this is not what we want. We want to have first servers that are getting all the pressure from the internet and then dispatching all the data and the processing over new servers, but in a controlled way. And for that, then what we need is really having request timeout CPU per request. CPU per request, that means that really you shoot everything, you want to close everything down. But here, we want to allow a number of maximum of instance. Why? Because we don't want to let Google run over your credit card and the number of instances it wants. And it will provoke some service interruption if you are not tuning in the right way, and also the number of concurrent requests. And then Ktor will run, and you will see that it's still running, but then you need to understand how fast your requests are performing with Ktor inside that. The thing that is quite curious is that if we were using rate limiting, and then we were provoking HTTP 429, and then also when this maximum of concurrency is reached on your container, this is also provoking some rate limiting. And then we were a bit confused about that, having the rate limiting or rate limiting policy, or also the container that was also blocking our stuff. And behind that, you have to handle your queue size, your timeout, and be sure that you don't really derive on that, and you don't have lots of data that are too much contained in your queue. Well, this is our story. Finally riding the massive data wave, and then we are done with that. Not done, but where we are today. Today, yeah, we still have this serverless Kotlin stack, and we are super proud of that, because then every day we are happy to deploy, and we are really handling billions of events per customer. And this, something in 2 months, we were able to have our first experiment, and then learning and then scaling over 6 months, we were really ready to have all the full scalability, for our infrastructure. That's really interesting, and really today, really we are super happy to have this capacity to auto-scale with only a few containers. That means that each time we try to pop something, we only have a few instances, and then it auto-scale around with the bandwidth that we need. And then for us, as a startup where we need to discover our value, our data, then we can really plug and play with messaging, with delivering data on new container, and then it's quite easy to do that. The other stuff that really we need to tune is clearly making our production service more effective in terms of cost, and trying to continue to explore solutions for Kotlin backend development. Do we use native? It's JVM, it's pure JVM application still then, and we didn't went too much into investigating for GraalVM or native perf. Then still think that perhaps we may tune to continue to gain some production stuff. A huge thank to all the team that really is working or have worked with us, and because it's a crazy adventure, and being able to capture billions of devices of data, then really that's really super, super nice. And then I'm really happy to thank them, all of them. And finally, this is some success story, because we have a few customers that we starting since this year that we are monitoring a few applications. Then we are monitoring third-party integrations and performance. We are monitoring stateless architecture with Plum, and then with Canal Plus in France, we are monitoring architecture performance, object creation, and scope tracing. Then all of that, you can, if you want, you can check on our website. We are also hiring. If you want to be part of the team, then we'll be happy. And that's it for me. I will be happy to answer your question. Thank you very much.